All right, so if they give you a function and tell you to find f of whatever, you're plugging whatever they put in that parentheses in for the what? And for the x, right? So if you have f of x, they tell you f of 0, you're going to replace the x with a 0. So we're going to go in here and replace all of our x's with zeros. So that'd be 2 times 0 squared plus 0 plus 1. And what would that equal? That would equal 1. If 0, 0. Second one, what are we plugging in? -2. Make sure that you put parentheses around a negative every time, especially if you have power. The -2 went in for both of our x values. So 2 we get. Okay, so for our first one, are we going to do the times 2 or square it first? Square it first. The -2 squared is times 2 is 8 plus -2. 6 plus 1 is 7. And there's no shame in just typing it in exactly like that in the calculator. There's no problem, no problem with that. Alright, our next one, I really like this kind where it's just f of a variable. This is saying where there was an x, we're going to replace it with an a. That's not too bad. 2a squared plus a plus 1. Is there anything that we can do to combine any terms or simplify that at all? Nope. So that would just be your answer. On our last one, what's going in for our x values? A plus h in parentheses. So 2a plus h squared plus a plus h. I could put parentheses here, but it doesn't really matter if it was plus sign. There's no operation with it. If you want to do that, you can. Would you like to leave it like this? I'd like to, but we don't need to. If there is something that is squared and it's got your two terms there, we have to actually control that. So what should we do if we have something that's squared? We need to write it how many times? Why? It's going to take a couple lines to simplify it all. I just wrote it twice because it said it's squared. So what do you think we're going to do next? Distribute, we'll leave our 2 in the front. A times A. And AH. Another AH. And what squared? H squared. All of our parentheses gone. No, so what, no. Oh, we need to combine these two, don't we? How many AHs are there in the middle? You might want to, if you have a highlighter, you might want to highlight what you have in parentheses. For a lot of these problems, you're going to have to square a plus h. So instead of going through all of these steps, it's going to always be a squared plus 2a h plus h squared. Go from here to here. So if you just want to make sure that you can see that in your, and if you want to skip from there to there, that's okay with me. write it out. Okay, now our parentheses are not gone, so what do you think we should do? Distribute our cube. There are two, all three of those. 2a squared plus 4a plus 2a squared plus a plus h plus. Anything we find? Okay. So that is what f of a plus h is. So f of a was just 2a squared plus a plus 1. You introduce this a plus h instead, and then you need to do all kinds of fun stuff. Okay. But the reason that I had us do f of a and f of a plus h is we have a special thing called the difference quotient that we're going to do. And to do the difference quotient, you have to have the f of a plus h and the f of a. This is the difference quotient in each letter of the thing. And sometimes you're asked to do that, but you need to know that before you do this part, you've got to do this separately. These are the difference quotient. Very important in calculus. And it's similar to what y'all did with your average rate of change. You did a problem like this. So this is the difference quotient. Sometimes you'll just be asked to find this. But before we can start plugging things in, you have to know what f of a plus h is. You have to know what f of a is, and then you just substitute it in. Okay. So you see how we already know what f of a is? We did that. Did we find f of a plus h? We did all of that work. F of a plus h is always this stuff that's on the bottom part. So we're just going to plug in what we just found. A plus h, we just found. And f of a is simplified. So when they ask you to do this, they won't have you do the other parts first. You have to know I need to do f of a separately and f of a plus h, and then start to plug it. So f of a plus h, that was all of this stuff, right? This is f of a plus h. So I'm going to write that in the f of a plus h. Okay, so I wrote f of a plus h, now I'm going to do minus, and what's going to come next? The f of a, and this was f of a. I'm going to put it in parentheses because after subtraction, you get now this is f of a, and for f of a, for f of a. And this is all over what from our equation I want to do? All over. This looks kind of like a crazy mess, but here's a hint or a tip or just kind of a trick I'm going to tell you. Everything that's in this f of a parenthesis here, every single time, is going to get canceled out with something that was before it. So those are all going to go away. So we're just going to cancel out what we see. So we're subtracting a 2a squared, we're subtracting an a, and we're subtracting an 1. You guys see a 2a squared minus a 2a squared, you see how we can cancel that out? That's gone. That's. I got an a. Was there an a to start with over here? That's a. Got a. Do we have a 1 that'll go away? 1 minus that 1. Everything in that parenthesis in the f of a is always going to go away. And what do all things have left, or have in them that we have left on the top? They all have an 8, which is good, because what are we going to have to divide them all by? 8 and 8. 4ah plus 2a squared h. They're all over h. So we divide every single thing by h. divide 4AH by H, what do you get? 4A. 2H squared by H, 2H. H divided by H, what's 4 divided by 4? So what's H divided by H? And that is your formula. You see how it was nice to have already had the f of a plus h and f of a done before you start to plug in? Some people try to do all this stuff. People try to do all of this work when they're doing this, but it's better to already have that simplified and you can just plug it into that part. So when they ask you to do this, think, oh, okay, I need to do these two parts separately first, and then I can just plug them in that. That's our evaluating function. Now we're going to evaluate some piecewise functions. Do you remember seeing a piecewise function before? Maybe. Yes. Maybe not write them down. Piecewise functions are functions that are broken up into, what do you think? Pieces, right? There's not just one equation that defines the whole function. There are multiple equations, and it'll switch. And they'll tell us, like, oh, you've got this equation going on, and at this number, you're going to switch to another equation. And then at this other number, you're going to switch to another equation. So it's broken up into pieces, and the pieces have specific numbers where they are. You want to see one? See what it looks like. X plus 2 and x is less than -3. It's just the number 4 if it's between -3 and 2. And if it's x squared minus 5 if x is greater than or equal to 2. How many pieces do you have for this function? We have 3 pieces. What are the switching numbers where it switches from one to another? There's 2 numbers where you know that it'll switch from one equation to the next. -3 and 2. That's our numbers where it's going to switch. Before you get to -3, you're going to use the first equation. And then 2 will tell us to switch to this next. Okay? Some people like to see a piecewise function on a number line because it helps them to see numbers that way rather than inequality signs. So I'll write that out and you can do that with your problems if you want to. Does that help you? If I had a number line, I'm going to split it up into 3 pieces. We said our switching numbers were at -3 and 2. Right? For all numbers that are less than -3, which equation would you use? If it's less than -3, which equation would I use? X plus 2. So I just put this on this section. If they give you a number that's less than -3, like -4, -5, -6, you're going to plug that number in. What equation are you going to use if it's between -3 and 2? He says between just 4. You can't really plug it in. Your answer is just always going to be 4 if you're between -3 and 2. They give you an x value or something. And if you are given an x value that's more than 2, which equation would you plug it into? X squared minus 5. All right, how do you guys evaluate a couple numbers that you have to figure out first which equation you use. And once you know what equation you're going to use, you plug them in. Evaluate that. I'm going to try f of -4. Here that is. Try f of 0. Try f of 2. And f of So the first thing you do is think which equation am I going to use. I'll help you on the first one. -4 is in which of these categories? First, second, or third? The first one because it's less than -3, right? -4 is less than -3. So we're going to plug -4 into this equation. -4 plus 2. What is -4 plus 2? -2. That's a negative. You guys try the -3. First step is which equation am I going to use? Second step is plug the number into the equation we have. All right, our next one, f of 0. Are you going to use the first, second, or third equation for 0? The second, because 0 is between -3 and 2. And it just tells you that if you have a number there, your answer is just going to be 4. Is there any x to plug it into? Nope, the answer is just 4. If you have anything in between -3 and 2, you just have an answer. All right. Well, what about f of 2? Are you going to use the first, second, or third? The third one because it has the equal to with the 2. Okay? As your numbers where it splits, you have to find the one that has the 2. I'm going to plug that in. 2 squared minus 5, and that equals -1. Okay. And which equation are we going to use for 8? The third one is 8 more than 2. It's in this section. 8 squared is 64, minus 5 is 59. How to make sense to you guys when you see pick the equation that you use in programming. Right, and our very last thing today is to decide what the domain is going to be if they're giving us an equation. And our domain is what all of the possible x values can be. What x values are good and aren't going to cause any problems. And problems are when an equation is going to be undefined. So you guys remember when things are undefined? What types of things can be undefined or non-real answers? If we have a 0 in the what? In the bottom of a fraction, which makes your slope relative. So that's an undefined answer. We can't have zeros in denominators. And what else do we get non-real answers? Yeah, with the things under the square root are negative. We can't have negatives under the square root, and we can't have zeros in the denominator. So we are going to make sure that when we have these functions, that we don't have zeros in the denominator, And what's underneath our square root has to be positive. It could also be 0, so it's got to be not negative. For that. So with our domain, these are our possible x values. And our problems are when we have non-real answers or when our answer is undefined. So our two main problems we have something that makes the denominator 0, that's not going to be in our domain. We can't have it. We can't have a 0 in the denominator. And even roots, like a square root or a fourth root, or even roots. The number underneath the root must be greater than or equal to 0. It cannot be negative. So we cannot have a 0 in the denominator, so we're going to see what makes it 0. We'll say we can't have that. And if we have an even root, like a square root, fourth root, sixth root, eighth root, those have to be greater than or equal to 0, the numbers underneath. Odd roots, if you have an odd root, third, fifth, seventh, it doesn't matter if it's positive or negative. You can do like a cube root of a negative. When you have an odd number of negatives, that just stays negative, so we don't have those same rules with odd roots. The square form. Okay. If our equation does not have any of these problems, the answer for our domain is just going to be all real numbers because we don't have anything that limits it. Nothing will give us an undefined or non-real. We're going to look at 4 problems and see what our domain is. Might get this. Over 2x minus 8, 3x over x squared plus 6x plus 8, and then the square root of 6 minus x. For our cursor, you always want to look, is there a denominator or is there a square root? Is there one of those? The square root is like on B, that's the square root sign. If you have a square root sign or denominator on A, on the 3x plus 2. No, so there's no number that we would plug in for x that would make anything undefined. It's not going to cause something to be a 0 in the bottom. There's no bottom. It's not going to do anything with square root because we don't have a root sign in there at all. So if that's the case, it can be any single number, any number at all. So I'm going to show you the 3 different ways that you could represent the domain in words with the graph and also interval notation. We're just going to write it, and we just write all real numbers or all real. The domain, because there is no denominator, there is no square root. Occasionally, after a function like this that doesn't have any problems, they might like write an interval out to the outside or write something with inequality signs. If they have a comma after it with some kind of interval, that interval is whatever the domain is. But if there's nothing after it, we don't have any problems. Sometimes they will limit it. So if you see something after the fact, that's what the domain is. All right, if you were doing a number line, how would you say all real numbers? The whole thing, right? Yeah. You're doing that is the entire thing. And then, if I was going to write this in interval notation, there's one interval, right? One thing is shaded. And where does it start? Negative infinity. And where does it stop? Positive. So those are the 3 ways to represent the domain of that number. For our second one, we have a denominator or square root. Yep, we have a denominator. And what can it not be? It cannot equal 0. So what number could you plug in there that would make it equal to 0? 4. Yeah, if you plug 4 in there, you would get 0 in the bottom, and that's not going to work out. So the one number that we cannot have in our domain is 4. If you're unsure of how we got 4, you can always do this. So take your denominator, 2x minus 8, we do not want that to equal 0. So let's see what would make that equal to 0. Add the 8, divide the 4, x cannot come up. We do not want it to be 0. What made it equal to 0 was 4. So we don't want 4. How would you say everything but 4 on the number one? Outside of 4, what do you put on the 4? Open circle, some people call it a whole thing. But 4 gets an open circle and everything else gets shaded. To write this in interval notation, how many sections are there on this graph? How many shaded sections? There are 2 shaded sections. Where does the first one start? Negative infinity. It stops at 4. And the second one starts at 4 and goes to positive. We have more than one and 2. Let's look at our third one. We have a denominator or a root. Denominator. You don't see a square root sign, we're not sure about that. We have a denominator, and what kind of denominator not equal? It cannot be 0. So let's figure out what makes it equal to 0. So we don't need to do that anymore. What do you do first? Factor it. What is it going to be? 2 and 4. So our answer is positive 2 and positive 4? No, we need to have. So x cannot equal negative, and x cannot equal negative. I'll make that one. -2, -4. We don't want it to be those two. We're going to draw what kind of circles? Open circles and say everything else. And how many intervals or how many sections are there on this graph? Three sections. There are 3. First one is from -infinity to -4. The middle one is from -4 to -2. The last one's from -2 all the way to. Alright, and on D, we've got a square root. So what has to be true for square roots? Stuff under the square root has got to be what? Maybe right at the top. It's got to be positive or 0, or a way to write that is going to be greater than or equal to 0. But if you see something under the root, just write greater than or equal to 0, and we're going to solve that. That's what our domain has to be. We're going to solve this, what's going to be moved first. 6. I'm almost done. X is almost by itself. Divide by -1. And that's our red flag. What's going to happen to this sign? And X is greater than or equal to 6. When you have inequalities, not inequalities, when you have roots, your answers will be inequalities like this. When you have denominators, it'll be the cannot equal. X is less than or equal to 6. Are y'all okay doing the graph and the interval notation for that one, or do you want to put it down there? What kind of circle on 6? Above the left is the left hand. And -infinity. And you can always check it to set our numbers. The good numbers are the ones that are less than 6. So if we pick something more than 6, it would give us a negative, right? That's what we don't want. Something that's more than 6 would be negative, right? 6 -7 is 1. That was pretty perfect.